Let's talk about the actual methods used for the design for natural ventilation. The air move based on two different characteristics of the air. The first air move from location with more pressure to a lesser pressure, and that is what we call a wind. And the second feature of the air movement is that hot air rises. Hot air rises because hotter air has lesser density and cooler air has higher density. There are two different general way of natural ventilation utilize exactly these two different features of air movement. One is wind driven and the other is buoyancy driven. Let's first talk about wind driven ventilation, which is using a flow that is created by pressure difference based on the geometry of the building. If we draw a diagram, it becomes like this. Let's say wind is coming from left to right. On the windward side of the building, you have a positive pressure built up, and the leeward side of the building, you have negative pressure built up. And if we locate two sets of opening, one for incoming air, which is inlet, one for where air come out, which is called outlet, and internal flow rate is created. Even for same surface with same positive or negative pressure varies based on the magnitude of its pressure. As you can see, this diagram represents the variation of the positive pressure on one side. For example, this point has more positive pressure than other points. And for the negative pressure side, this point has the biggest negative pressure for the leeward side of the facade. We called this magnitude wind pressure coefficient. Our goal is to control the flow rate, which is the amount of air that goes through, determined by these two factors. One is wind velocity, which is pretty obvious. You have more wind and more flow rate is made even though it's a same building design. And second factor is what we control through the design of our building, controlling the wind pressure coefficient that we just talked about. For that, we want to locate our inlet at the location where the highest positive pressure is built up, and we want to locate an outlet where the highest negative pressure. If we do that, then we have the most amount of difference between inlet and outlet in terms of pressure, then we will have the maximum amount of flow rate. As you notice here, if you have flat roof, you have a negative pressure at this location, but as you tilt up, becomes a zero at certain point, and as it goes beyond some point of angle, it starts to act more like a vertical wall, and you have a positive pressure, and this side becomes a negative pressure. So now let's look at a plan. Let's imagine wind is coming from left to right, and let's start to locate an opening. If you have a single opening, do you think the wind will go in? Theoretically, no, because we don't have any difference in pressure coefficient. We don't have any flow of air going through. The cross ventilation between window happens when we have two opening on the windward and leeward side. Opening size is ideally the same for both of inlet and outlet. The ventilation from wind coming from the diagonal direction can vary based on the location and size of window. For the upper example, notice that the two windows are located on the different sides of the building. But also notice that they have the identical wind pressure coefficient. If the two windows are identical in terms of wind pressure coefficient, the cross ventilation will not happen. On the contrast, for the example below, even though the building design is the same, creating a positive pressure on this side, negative on this side. Therefore, the wind is crossing through the building from positive to negative pressure. Ventilation happens when there is the difference in the wind pressure coefficient. On the upper case, even though both of the windows are equally positive pressure, the wind will blow from a window that has more wind pressure coefficient and goes out through the window that has less wind pressure coefficient. On the other hand, the below case shows where the two windows with same wind pressure coefficient will reject the air from coming into the building. You can locate a fin in a strategic manner in order to fix some of these conditions where wind will not go into the building. Uppercase shows a good example. By locating fin to one side of the door for one door and the other side of the window for the other door, you created a positive wind pressure coefficient for the left side door and negative pressure coefficient for the window on the right side. Therefore, cross ventilation will happen. And for the example on the bottom, since you've located fins on the same side of the window for both window, the both window now have same positive pressure, which will not allow cross ventilation to happen. There are some other wind characteristic that's being used to aid the wind-driven ventilation. One is a Bernoulli effect. This is venturi tube with where we control the air movement to be increased at certain location by controlling its width. And at that location, we can provide a little opening where the air movement is increased. And because of its pressure differences that is created at the opening, the outside air will be sucked in to follow the main air movement. This is the principle of venturi passive ventilator. When we want, we can open up these louvers. High negative pressure zone will aid the air inside to be sucked out of the interior of the building.